Department of Collegiate and Technical Education welcomes you for learning and management system program first year BE common to all course engineering physics course code 18 PHY 12 bar 22 fourth module laser spark session 4 learning outcomes. At the end of this session, students are able to understand the available modes of vibration in the carbon dioxide state, principle, construction, and working of carbon dioxide laser, some key points of carbon dioxide laser, finally, the possible questions. Possible energy states of vibration in carbon dioxide. There are three modes of vibrations in carbon dioxide state. First one is bending mode of vibration. Second one is symmetric mode of vibrations. Third one is asymmetric modes of vibration. Let us discuss in detail each mode of vibration. First we go with bending mode of vibration. In this mode of vibration, the carbon atom moves up while the oxygen atom move downward perpendicular to the molecular axis and vice versa also true. It is indicated by 0, 1, 0. This is the least mode of energy. The notation used here represent the first 0 indicate the symmetric mode of vibrations is 0. 1 indicate the molecules vibrating with bending mode with 1 units of fundamental vibration, and this 0 indicates there is no asymmetric mode of vibration. It is purely bending mode of vibrations. Symmetric mode. In this mode, the oxygen atoms oscillate about the fixed carbon atom along the molecular axis. This is the intermediate mode of energy and it is indicated by 1, 0, 0. You can observe here how the oxygen atoms will oscillate about a fixed carbon atom. One can observe here both the oxygen atoms approaching towards fixed carbon atom along the molecular axis. In another turn, the oxygen atoms are departing away from the fixed carbon atom. Like this, it keep on oscillating about fixed carbon atom. Finally, the asymmetric mode of vibration. In this mode, the oxygen atoms moves one direction while a carbon atom moves in opposite direction along the molecular axis and vice versa. This is the highest mode of energy indicated by notation 0, 0, 1. As I mentioned in earlier case, here the first 0 indicate there is no symmetric mode of vibrations, middle 0 indicate there is no bending mode of vibration, 1 indicate the molecules vibrating purely in asymmetric mode with fundamental mode of frequency or fundamental unit of vibrations. One can observe the way how the atoms will vibrate in this mode. Here you can observe both the oxygen atoms moving right side whereas carbon atom is moving left side and vice versa also observed here. The oxygen atoms moving left side, whereas carbon atom is moving right side. In this way, the carbon and oxygen atoms keep on vibrating in asymmetric mode. Principle, construction, and working of CO2 laser. Principle, electric discharge. Construction, the CO2 laser consists of a quartz discharge tube of length approximately 2.5 meter and area of cross section is 50 millimeter square. The discharge tube is filled with active media composed by carbon dioxide molecules, helium molecules, and nitrogen molecules in the ratio of 1 to 3. The discharge tube also provided the electrodes to produce electric discharge in the gaseous mixture. One of its edge of the discharge tube is pitted with partially reflecting mirror to bring the laser beam outside. Once threshold photon density reached inside the quartz discharge tube, whereas other side is pitted with 100% reflecting mirror to enhance the photon density in the discharge tube through multiple reflections. Working, the electric discharge is produced in the active media, that is gaseous mixture. Electric discharge is nothing but liberation of or releasing of free electrons in the active media or gaseous mixture of discharge tube. Whenever the electrons are liberated, the nitrogen atoms will readily excites from ground state even to the higher energy state E2 through inelastic collisions. One can observe here the energy level diagram for CO2 laser. Here, the left hand side, you can observe the energy levels for N2 molecules, whereas the right side, you can observe energy level diagram or energy levels for CO2 molecule. Together, we call energy level diagram of CO2 laser. The excited N2 molecules will return to the ground state by transferring their energy to the CO2 molecules which are present in the ground state through inelastic collisions. This is also called as resonance energy transfer because the highest energy level of N2 and CO2 almost equal. Therefore, energy transfer can easily takes place to lift the carbon dioxide molecules present in ground state. Therefore, the CO2 molecules will excite to the higher energy state, say E5. Since E5 is the metastable state, therefore, the population inversion could be achieved between the two sets of energy levels. One set is E5 and E4, and another one set is E5 and E3. So this increases since E5 is metastable state, so the population in E5 level increases once it reaches threshold photon at CO2 density. The CO2 molecules spontaneously decay from E5 to E4, which generates a photon. This photon triggers the atoms from E5 to E4, generating a laser beam of 10.6 micrometer. If any one of the atom decay from E5 to E3 by spontaneously, this emits a spontaneous photon. This photon have right energy to trigger the atoms from E5 to E3 so that which generates a laser beam of 9.6 micrometer. Therefore, in this case, one can observe two different types of laser beams. One is transition between E5 to E4 generates the laser beam of wavelength 10.6 micrometer, which is lies in infrared region. The transition between E5 and E3 generates the laser beam of wavelength 9.6 micrometer, which is lying in infrared region, whereas E3 to E2 uh, uh, decays or transition takes place through the collision between walls of a discharge tube. Since E2 is highly metastable, therefore the atom spends very large time here. It stops to decay from E1 with immediate manner. Therefore, so lasing action stops. So in order to increase the laser action quickly, the helium atoms are used in E2 level. The helium atoms depletes the CO2 molecules which are present at E2. Therefore, the CO2 molecules decays from E2 to E1 through inelastic collision with helium atoms. Therefore, the helium atom increases efficiency of the carbon dioxide laser. Key points of CO2 laser. Output is continuous. Active media is carbon dioxide, nitrogen, and helium atoms. Population inversion achieved by the mode of electric discharge. Wavelength range. There are two wavelength regions are there, 10.6 micrometer and 9.6 micrometer. Applications mainly in mechanical industry and medicine. Some possible questions. What is the active media in carbon dioxide laser? In the carbon dioxide laser, the active media is carbon dioxide, nitrogen, and helium forms active media. What aid is used to achieve the population inversion in the carbon dioxide laser? Here, the electric discharge is used in the carbon dioxide laser to achieve population inversion. Why the N2 molecules readily excites to the highest energy level when the electric discharge produced in the gaseous mixture, since N2 molecules proportion is more than helium and more than carbon dioxide molecules. N2 molecules proportion is more than carbon dioxide molecules, therefore readily excites to the higher energy level. What is the role of helium atoms in the CO2 laser? So helium atom makes the carbon dioxide as a continuous one by depleting immediately from energy level E2 to E1. Therefore, it enhances efficiency of carbon dioxide laser. Mention the output range of CO2 laser. As I mentioned earlier, 10.6 micrometer and 9.6 micrometer. Define type of vibrations in the carbon dioxide gaseous state. There are three types of vibrations: bending mode, symmetric mode, and asymmetric mode of vibrations. Write the modes of vibration in the ascending order of their energy: bending mode, symmetric mode, and asymmetric mode. Why one of the end of discharge tube is fitted by 100% reflector to enhance photon density in the active media through multiple reflections. Mention the media where the lasing action takes place in the carbon dioxide laser. The CO2 is the media where the lasing action takes place. Define different modes of vibration. As I mentioned earlier, bending mode, in which the carbon atom moves upward while oxygen atom moves downward, and vice versa. In symmetric mode, the oxygen atoms oscillates about fixed carbon atom, whereas in the case of asymmetric mode of vibrations, the carbon atom moves one direction, whereas oxygen atoms will move in opposite direction along the molecular axis. These are the different types of modes of vibrations. Content developers list, and thank you.